So in this video we're going to learn a little bit about how we use these special triangles that we have just been talking about. We're going to be doing this for quite a bit over the next, we'll say 2 years. It comes up every now and then. So you do want to get familiar with it. You are more than welcome to keep solving them the way that this video presents, but another few days we'll probably learn an easier method that once you get the hang of it makes these kind of problems very, very easy and very, very fast. So we're just going to run through a few here. The first one says find sine of 30 degrees. So for all of these we're going to try and draw a triangle somewhere on the coordinate plane. So for 30 degrees we're going to be going off something like this. Okay, right here is my 30-degree angle. And so I want to remember the sides that we just learned about for a 30, 60, 90 triangle. If you remember, that would have been 1, this was square root of 3, and this was 2. And so if we are standing at 30 degrees, sine is opposite over adjacent, so sine of 30 degrees would be 1/2. Okay, we move over to the second question there. It says find tangent of pi over 4. Now remember, pi over 4, that's radians, same thing as 45 degrees. So we're going to go through the same sort of setup. We're going to think about where would 45 degrees sort of fall on a coordinate plane. It'd be somewhere up here in the first quadrant. It doesn't quite matter where I stop here, but that's a 45, 45, 90 triangle. And the sides of a 45, 45, 90 triangle, remember we made this one, and this square root of 2. So tangent of pi over 4, or tangent of 45 degrees, tangent is opposite over adjacent. So I would have 1 over 1, which just reduces to the number 1. Question 3, find cosecant of 315 degrees. Well, now all of a sudden it gets a little bit more difficult. We need to think about where 315 degrees is going to end up. So again, we're going to draw a coordinate plane. Oops. Helps if I have the pen selected. There we go. Okay, so where does 315 degrees fall? So remember, we're going to start measuring here. We're going this way. This is 90. This would be all the way to 180. This is going to be 270. And over here would be 360. So if this is 270 and this gets me to 360, it's somewhere in between here. We just need to think about what angle is left over. So I'm going to draw in an angle like this. We'll talk about what angle it's going to create here in just a second. Remember, we always draw a line straight to the x-axis from there. Okay, so now our stuff happens to be in the fourth quadrant. This angle right here that I'm drawing in, that rotation was the 315 degrees. Okay, but we got to think about what's left behind there. In this little piece right here be another 45 degrees in this little chunk right here that would get me all the way to 360. So 315 degrees plus 45 gets me a complete circle of 360. So I know that right here is 45 degrees. So what else is going to be a little different in this question? We fill in the sides of our triangle. Of a 45, 45, 90 triangle, we'd have that. The only difference here is that the point down here would have a negative y value. So I'm going to make this be a length of -1. And I know that seems kind of silly to have a triangle that has a side length that's a negative value, but the reason we can do this is now we are allowed to talk about 315 degrees in terms of 45 degrees. Putting this negative symbol here and using that as a side length allows us to make that change. I'm not going to get into too many details about that here in the video, but feel free to ask in class and we can talk more about it. Okay, so finishing up the question, I'm using this angle right here to solve the problem. I want to figure out cosecant of that angle. Well, remember what cosecant is. Cosecant is the reciprocal of sine. So if sine of this angle is opposite over hypotenuse, by the way, hypotenuse is always positive, I'd have -1 over square root of 2 for sine. I'm going to flip that for cosecant. Okay, so my answer up here would be if sine was -1 over square root of 2, this is going to be square root of 2 over -1, which just reduces to -√2. Moving right along, example 4, find secant of 5 pi over 3. So another one that's in radians. So I'll have to think through that a little bit. And again, it would be nice if I had my pen selected. There we go. Okay, this one a little bit tougher. Remember, pi over 3 is like 60 degrees. And I have 5 of those, right? I have 5 pi over 3s right here. So that's one way to think through it. Another way is to say, well, here's 60 degrees, here's 1 pi over 3. And of course, this would come up. We'll let this run through here a second before we continue on. There we go. Okay, so this would be 1 pi over 3. This would be 2 pi over 3, or 120 degrees. This would be 3 pi over 3, right? 3 pi over 3 is just like pi, which is 180 degrees. Okay. Out to this angle right here, this would be 4 pi over 3. 5 pi over 3 would be somewhere right around here. And another 5 pi over, or sorry, another pi over 3 would get me to 6 pi over 3. 6 pi over 3 reduces to 2 pi, which is a complete circle. So we will be practicing that a lot down the road, but my angle is going to end up somewhere in here. Okay, from here all the way around, this was 5 pi over 3. And if I draw a line straight to the x-axis again, so I create a right angle there, I would have, let's see if I can squeeze that in, maybe I'll do this. We would have pi over 3 left right there. So again, 5 pi over 3 plus 1 pi over 3 gets me 6 pi over 3, which in this case gets us our complete circle. And then this is also, think of it like 60 degrees if that helps you. Okay, so if that's our 60 degree angle there, we know some things about a 30, 60, 90 triangle. We know this would be a side length of 1. This would be a side length of square root of 3, and this would be a side length of 2. Again, it's in that fourth quadrant, so this is going to be -√3 for that y value. I want to find secant of 5 pi over 3, which means I consider cosine. Cosine of that angle is, the adjacent is 1, hypotenuse is 2, so cosine of this would be 1/2. I need to take the reciprocal, so my answer would be 2 over 1, or just 2. So in this case, there are no negative symbols, even though we have this thing being in the fourth quadrant. It just works out that we still get positive. And so again, we'll do lots of practice, with that. You'll come to understand why sometimes things are negative, why things are positive. One more example here. Let me scroll up just a little bit. And we will erase that, I think. There we go. Okay, so this says find cotangent of theta if cosecant of theta equals 2 and cosine of theta is less than 0. So again, we will be drawing some pictures here. A lot of things to think about. Let me begin by making just a typical coordinate plane. So here we have cosecant, which is kind of related to sine, is positive. So we have to think about where would sine be positive. And I'll just tell you that sine will be positive in the top 2 quadrants. We'll probably do more of an explanation of this in class. But if you think through all the possibilities of angles in these 2 quadrants where you'd be dealing with opposite sides and the hypotenuse, this is going to be where those combinations are both positive. Okay, where is cosine of theta going to be negative, less than 0? that's going to occur in these two quadrants, quadrants 2 and 3. And again, the reason is, if you think about all the triangles that you can create in these two quadrants where the adjacent side would be negative, hypotenuse is always positive, so that wherever that kind of ratio would be negative, it's only going to happen here. And if you're not quite sure why that is, like, ask a question. I do plan on talking about that in class and doing a more of an explanation, I suppose, of it there. So we need cosecant or sine to be positive because we have a positive 2, and cosine to be negative. That's going to be in the second quadrant then. So we need to think about drawing a triangle in the second quadrant. Excuse me a second here. Okay, so we're drawing our triangle in that second quadrant. Remember, if cosecant of theta is 2, that means sine of theta is 1/2, right? They're reciprocals of each other. So I need to think of a relationship where the angle that I create right here, this is going to be the theta. Really, this is kind of the theta that I'm talking about. But we're going to use the theta that we have right here to get us there. I need the opposite side there to be 1. And this to be 2. And then that would make this be a square root of 3 because just the type of triangles that we know we're working with here. Okay, 1, 2, and square root of 3 are typical sides that we see. No, so we need to now think what angle would get us a triangle like that situated there. And the answer is going to be 30 degrees. Okay, so this theta is 30 degrees. Really, I should add this. This would be a negative root 3 there, right? Because we're in that typical quadrant. So now we can see that from this angle, cosine would be negative root 3 over 2. Sine would be 1 over 2. Cosecant would be 2 over 1, etc., etc. But I want to really focus on finding this angle right here. That's really the angle that we're talking about. Well, if this is 30 degrees, all of this is 180. So in the end, I just have to say, well, what's 180 minus 30? I get 150. That's really the angle that I want to use for this particular questions. Okay, a lot of stuff there. Jot down any questions you have. Sure, there will be some, and that's okay. Just make sure you jot down some specific questions.